Hi all. We're going to talk about integer exponents today. And as a review of exponents, let's start with, come on, go ahead and work for me here. Thank you. If I have 2 to the 4th, let's label this. 2 is my base, and 4 is my exponent, sometimes also called power. Now, the exponent tells me how many selfies the base is going to take. So, in this example, my base is 2, my exponent is 4. That means my base is going to take 4 selfies. Boom, 1 selfie. Boom, 2 selfies. Boom, 3 selfies. Boom, 4 selfies. And they multiply each time. 2 times 2 times 2 times 2 equals 16. So 2 to the 4th is the same as 16. Now, what do we do if we have an exponent if we have a base to the power of 0? So what about something like 2 to the 0? Is it 2? Is it 1? Is it 0? Is it, I don't know, I give up, I can't do this? Well, let's take a look at some things. We know that 2 to the 4th is 2 times 2 times 2 times 2, which equals 16. 2 to the 3rd is the same as 2 times 2 times 2. The 3 tells me how many times I multiply the 2. And 2 times 2 is 4 times 2 is 8. Well, and 2 to the 4th, whoops, that's backwards. 2 to the 2nd power, or squared, is 2 times 2, which equals 4. And 2 to the 1st power, or just regular 2, equals 2, which is the same as 2. Let's look at this column for a moment. That needs to be a lot thicker. Let's look at this column for a moment here. What's happening? Well, what do we do to 16 to get to 8? I divide by 2. Okay, well, what can I do to 8 to get to 4? Oh, I can also divide by 2. And what about 4 to 2? I also divide by 2. So, whenever I'm counting down, when my exponents get to be 1 less, 3 is 1 less than 4, 2 is 1 less than 3, 1 is 1 less than 2, it's the same as dividing the number before by 2. Well, if we use that logic, then 2 to the 0 equals, well, 2 divided by 2. And 2 divided by 2 is 1. So 2 to the power of 0 is 1. Now, we can say that anything to the power of 0 is 1. So, any base raised to the power of 0 equals 1. So, 2 to the 0 equals 1. 9 to the 0 equals 1. 256 to the 0 power equals 1. No matter what the base is, when it's raised to the 0 power, it equals 1. What have a negative exponent. So what about if I have 2 to the negative third power? Well, let's look back at what we had before. So here is the chart before. Let's continue it. Well, if I do 2 to the 0 and I subtract 1 from the exponent, it's the same as 2, whoops, hold on, I need to get my pen back, 2 to the negative 1. Now, if I follow the same pattern as before, I'm going to do 1 divided by 2. Move that up a little bit. 1 divided by 2. Well, 1 divided by 2 is 1/2, or 1 2 to the 1st power. Okay, let's say 2 to the negative 2. Well, again, I'm going to divide 1/2 by 2, and that's going to give me 1/4. Well, 1/4 can also be written as 1 over 2 squared. So, if I have 2 to the negative third, I'm sorry, it's being cut off a little bit up there. 2 to the negative third is the same. I have to divide 1/4 by 2. 1/8, which is the same as 1 over 2 to the third, because this 8 matches with this 8, which is the same as this 2/3. So if you want to know where I got this 2/3 from and 8, how they relate, there you go. So we can say that any power, any base, that's raised to a negative exponent, a base raised to a negative exponent can be rewritten as a fraction with the numerator being 1 and the denominator starts with a D being the base with the exponent being positive. I suggest you take some time, review this video, copy down all the notes, make sure you have them. Tomorrow we're going to do some practice in class. Now, for extra credit, you may hand in an explanation of this comic. If you could explain why this is amusing or what the math involved in this is, I will give you 1 point of extra credit. Good luck, and I will see you tomorrow.